Describe what the situations have in common. A pendulum swinging, the average temperature each month in Texas, a heartbeat, the time for high tide and low tide each day. What's in common? Back and forth, repeats, right? The motion repeats. The motion or action. Repeats. Okay, come up with some examples of this repeating motion. Go ahead, hold it in. I want to see you hold it in your entire breath. The entire class period. You know what? Somebody came up with roller coaster last hour. A yo-yo. A repeating cycle. Motion, action. Clock. Yeah, clock would work. The minute hand on the clock. Some concepts here. Although, another motion that would be repeating itself would be James Dean. James Dean. The motion of him returning every year to the same class would be. All right, what? Sure. Concept. A function that repeats a pattern at regular intervals. That would be a periodic function. You know what we should call it? We should call it a James Dean function. One complete pattern. I don't stop. One complete pattern is a cycle. The horizontal length of one cycle. All right, period. And it's the period, not a periodic function, it's the period for the function. All right, that's enough. All right, let's look at some examples here. Analyze the periodic function. So we have a periodic function here because it's a function that repeats itself at intervals. Okay, I'm going to do one interval here, and that's going to be the cycle. Okay, so if I have start here, it starts repeating again right there. Okay, so this would be one cycle. That's a cycle. Go here. So that's one cycle. Now, the period is the length, so it's a measurement. So the period is a measurement of this cycle. Okay. So my period goes from here to here, and we're going to measure it. So the period is going to equal a number, and that number is 1, 2, 3, 4, 5, 6, 7. period is 7 units. Now, because we have to do this in 2 different ways, right? So we're going, here's my axis, right? Here's my y-axis and my x-axis. So the period is the domain. Why don't you do the range, huh? So my range, let's see, it starts here. And the max, so that's the min. And the max is going to be here. I was starting your class. Let's say the min, if this is my x-axis here. So my minimum here is going to be negative 1, 2, 3. And my max 1, 2, 3, 4, 5. So my range is 8 units, right? No, negative 3. No, I'm not sure. I can't see it. Okay, if I wanted to put this in interval notation, it would go from negative 3, including negative 3, to positive 8 units. Now, you could do that with, obviously with this too. Questions, comments, concerns? And I'm going to see if I got my other glasses. I really can't. All right. Oh, much better. Okay, number 2. Okay, I need to find the period. So let's trace a cycle here. It starts there. So it goes, gonna go up and starts again here. So there's one cycle. And let's see, this would be my period from here to here. So the period's going to be 1, 2, 3, 4 units. And the range is going to be from here to here. So the maximum, here's my x-axis. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Wow, I can't do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9. Anybody else count those? Somebody else count them. All right, so we're going to say 16 units, 7 plus 9. Okay, I'm going from negative 9 to positive 7, including those numbers. Okay? Now I got a headache from counting these stupid things. Excellent. The periodic function? No. Because the pattern doesn't repeat, it gets smaller and smaller and smaller. Is the function a periodic function? Yes, it is. So what's the period? Well, let's highlight a cycle. Okay, period. Going to be the x values. 1, 2, 3, 4, 5, 6, 7. And the range. Let's see, we've got a -3. 1, 2, 3, 4, 5, 6, 7, 8. Range is 11 units. Interval notation, -3 to +8. Questions, comments, concerns? I really got to get a new pair of glasses. Okay, blank is half the distance between the max and min values. Hey, look, it's the amplitude. And we have a formula for this. For the amplitude, it equals 1/2 times the max minus min. Okay, for the horizontal line midway, so it's going to be a what? That's right, midline. Between the maximum and minimum values. We have a formula for that. And that is 1/2 the max plus min. Okay, what's the max, what's the amplitude of periodic functions? We need the amplitude and the midline. All right, so we're going to need our x-axis. Here's our x-axis. Let's do, oh, we're going to need our max and min, right? So our minimum is -1, -2, -3. And our max here is 1, 2, 3, 4, 5. So the amplitude equals 1/2 our max, which is 5, minus our minimum value, which is -3. It equals 1/2 of 8, which equals 4. Our midline is y equals 1/2 max value is 5 plus -3 That equals 1/2 of 2. And 1/2 of 2 is 1. So y equal 1. So that's a horizontal line at y equal 1. That's our midline. Midline at y equal. Should we do it again? Sure, let's do it again. See my x-axis here. My min is right at the x-axis, right? So 0. 1, 2, 3, 4, 5, 6, 7, 8. Amplitude is 1/2 max minus min. Half of 8 is 4. Midline, y equals 1/2 of 8 plus 0. And my midline happens to be y equal 4. 1, 2, 3, 4. So that's my midline. Okay, what's your understanding of this concept? Let's see, it could be 4. I was listening to Mr. D. I was listening and taking notes. I was focused. I'm a disciplined, well-motivated student. Or it could be a 1. A 1 would be, I don't know a thing. I was vaping. I was vaping. Or I wasn't even here. I went to the pool room with toilets. All right. Questions, comments, concerns. You guys got a worksheet, didn't you? Bookwork or something? A worksheet? Are you good? Huh? Are you good? Are you good? Some of you didn't even finish.